Hello guys! Hello world! Hello Philippines! Okay, so I'm not yet oh sorry. Oh my gosh. Hello guys! Hello world! Hello Philippines! This is again I'm a singer, eternal voice. Okay, so it took me uh, so many days that I've been resting for any vloggings and any live streamings, right? So now it's a comeback for me. Okay, so I would like to tell you before going further another uh, very important theory. Uh, Not really that very essential theory, but at least you have an idea regarding cast. This is all about collision theory. Okay, so as you know that liquid and fluid are incompressible, right? So meaning to say the changes in the densities of fluids are not really that relevant, okay? Or the density gradient or density differences, because most of the times the fluid and the liquid uh, will not be mixed, though in other occasions in different processes I think there are also mixing, especially if they are producing liquid chemical products, right? I think so. But most of the times, only one kind of fluid will go through the, for example, through the pipeline, like that, through cross-sectional, uh, what else? Any process tanks, process vessels like this, or anything, okay? As long as the fluid will be accumulating there, something like that. Grabe. Okay? So, that's why it is incompressible talaga siya. So, at any time or any given temperature and pressure, the densities are not really that relevant. Though it will still be incorporated in your equation, but it's not really that very uh, what do you call this one? They're very essential. Okay, it's just only constant all throughout. Okay, something like that. Okay, but for gases, so the changes in density are very important. Okay, because these are compressible. Okay, substance. So meaning to say the density changes and the density gradients are really an issue for and relevant for gases. Okay, at any given time, temperature, pressure, and concentration. Okay, something like that. So in gases also we have these two theories: the collision frequency and the collision density. Oh my gosh! So what do you mean by this? Okay, so as you can remember, we have a lot of gases theories and gases laws, right? For example, the Gay-Lussac's law, no, Gay-Lussac's law, okay, the Charles law, what else? The ideal gas law, the Dalton's law, partial pressure, di ba? Yung mga ganun. Okay? And then the Pascal's theory of pressures also have, right? So remember, okay, the Boyle's law, okay, the Van der Waals uh, law for non-ideal gas, okay, like that. So there's a lot. So the gases are, lighter compared to the fluids and liquids. So meaning to say, the molecules are far apart with each other. Okay, meaning to say the collision of the molecules are not very strong compared to the liquids in which the molecules are very close together and compacted. Okay, so it is expected that the intermolecular forces or intermolecular molecules reaction in liquids are very strong because they are very close with each other. They are bombarded easily and collided easily compared to the gases. So this is the reason also that the gases at high temperature, the viscosity will increase. Something like that. It is more viscous sometimes like that. Okay? Like that. It's also the reason why the cold water or the hot water or cold water and then hot wind or hot air and cold air relationships, okay, where wind among them will go up and go down, something like that. So for example, hot water, okay, hot water, okay, so which of them, that water and the cold water, will rise easily, something like that, okay. So of course the hot water will rise easily, okay, and then the cold water will be down, something like that, okay, and the hot air also will go up easily, and then the cold water will go down easily because of the relationship of the molecules, okay. The hot air, okay, will goes up easily compared to the cold air. Okay, so it is more hot or it is more cold in the in the lower part. Okay, down level. Okay, if you turn the AC, the first area that will be cold first are in the bottom part. Okay, and then in the high part later. Okay, like that. Okay, so the hot air will be usually in the up because of the molecules are very close together and bombarded easily, something like that. And then this cold air, the molecules are farther with each other. Okay, something like that. Okay, so the hot air will go up and the cold air will go down. Something like that relationship. In collision's frequency, the formula is the number of one gas molecule per unit time. Okay, that's collision frequency. Okay, na collision density, number of collisions of total gas molecules per unit time. Okay, so based on my research on siya because I'll never encounter this before. Okay, in my education. Charot! Okay, so first time lang siya. I thought there is also like this, but we don't go in detail, okay? Because normally we will just read, right? For example, in a certain topic and there's an introduction, it's in there where we discuss the theories, principles, and concepts before having the problem solvings, right? For examples. And most of the times, because of time limited discussion, our instructors will not go deeper on the overview. But sure, this collision frequency and collision density are being also covered, but not really that a center of focus. Okay, because normally the most common and familiar theories and concepts will be discussed, right? And then we'll go directly to the problem solving. Okay, but these types of theories will sometimes be neglected. Okay, because that's not very common to the students. And and this is also the fact that the most of the examinations will get this kind of theories and principles because these are also the theories and principles that most of the students neglected. Okay, because we want also to push the students to think deeper and analyze deeper, not only for the common. Okay, the common are the density, the mass, the volume, mga ganun siya. Okay, the pressure, the force. So there are other principles and theories that are not common, like this: collision frequency, collision density, and there's a formula each. And me also as an engineer, I cannot, understand very well about this. Okay, based only my research. Okay, and I read a lot also. There's gonna be a theory like this. So I read also in my research, not really just extensive research, only personal research. There's a question also like this, asked in the board examination, something like that. Because I found out, I didn't memorize, okay? I didn't memorize something like that only because I am very fun watching those problems, okay, in the videos, in the YouTube, like that. Uh, their vlogs also. Some are do vloggings like that also, okay? If you go to YouTube, a lot of vlogs regarding mechanical engineers problem solvings, electrical engineers problem solvings, chemical engineers problem solvings, that all questions that been released from the PRC board examination. So I like to to watch those videos of them. Of course, I watch the chemical engineers because I am a chemical engineer, right? Okay, I can relate. Okay, maybe not really that 100%. I also watch others engineers examination, but particularly on the mathematics and the general engineering on E, because we have general engineering common to them also. Okay, right? A lot of engineering disciplines, right? But we have also subjects the same with them, like engineering mechanics, strength of the materials, yung ganun siya, electricity. We have also electricity subject. Okay? Like the advanced engineering mathematics, differential equations, differential calculus, integral calculus. Okay? Like that. We have the same subjects. Okay? All engineering courses. So that's the time I will go there to watch also their problems. Okay? But not most of the times. Okay? Sometimes I need to explore. But this time, this collision frequency and collision density, the question is like this. Listen. Wow. Listen to the song of my heart. Okay. So the collision frequency, so the formula is the number of one gas molecule over per unit time. So, ibig pala sabihin gas na molecule also can be applied to one certain element, especially the gas. That's called a molecule already. Okay, singular lang siya. For example, hydrogen gas. So that's molecule. Okay? Then hydrogen gas plus oxygen gas, that's molecules. Just following the rule of English grammar also. Okay? Like that. Okay? So molecule siya. Because you cannot say number of 1 mole of hydrogen gas over per unit, because that's not the definition. It's not mole, it's molecule man siya talaga. Okay? There's a difference ba if you say molecule and mole. Okay? Because a mole will never consider the molecular weight and atomic weight ba okay? But the molecule will consider that somewhere along with your computation. That's why it's better to use molecule talaga siya. Okay? And then for the collision density is the number of collisions of total gas molecules per unit time. For example, you have so many gases there. There are, combining with each other. For example, hydrogen gas, oxygen gas, helium, krypton, xenon, like that, right? So there's a lot of gases combined there. So the total of their collisions, gas molecules with S per unit time is the collision density. Okay, so the difference is very clear. Collision frequency referring only to one gas molecule. Okay, but the collision density referring to all gases combined with each other, total, but still collision. Okay, like that. In collision frequency, the collision is referring only to one gas molecule. But here in the collision density, so many gases molecules are being bombarded with each other. Okay? So the question is, samanto nakalimot ko siya. Okay. Which of the following produces a high collision frequency? Ganun siya. A, 1 mole of hydrogen. B, 2 moles of hydrogen. C, ganun siya, okay? 1 mole of oxygen. D, 2 moles of oxygen. Di ba confusing siya? Okay? So in here, there's no numbers given in the problem, only the theory. So it needs to be analyzed, okay, right? Because there's no given. How can you say that there's a more collision frequency in this gas compared to the other gas? There's no given. Okay, only to the answer. Sometimes this kind of question really confuses the students, especially in the examination. So this is the time we will apply the theory and principle. Okay, so for example, mole, your choices are moles. What are the formulas that involving moles of gases? So you think first for ideal gas law. Okay, it involves number of moles, so small letter n, right? The pressure times volume is equals to the number of moles times the universal gas constant capital R times the change in temperature, right? There's n there. And then also you will consider also the formula of the molar mass. Okay, how to get the molar mass? The molar mass will be the molecular weight times the number of moles. Okay, there's a number of moles man siya. Okay, molar mass number 2. Number 3, you will think also of Dalton's law of partial pressure. Okay, the total pressure of the gases will be equal to the partial pressures of each gas exerted on the surface. Okay, Pt is equals to P1, P2, P3, P4, P5, but this numbering is referring to different kinds of gases, right? Ganun siya. So, another thing also, again, Dalton's law of partial pressure, the mole fraction. Okay? The total mole fraction is equals to mole fraction of component A, mole fraction of component B, mole fraction of component C. Okay, and then to get each mole fraction will be like this. Mole fraction of A is equals to mole fraction of A over the total mole fraction, something like that. Okay? So those are your identification. Another thing, you will also think further atomic weight and the molecular weight. And the choices baya siya, number of moles naman siya dayon. Okay, so you will say, oh my gosh, I have to use the atomic weight and the molecular weight. So you have to multiply. So molar mass will be used here. Okay, molar mass, and the theory also that the gas, if it is more lighter, okay, it will escape more easily. If it is lighter, it will diffuse easily, it will escape easily. So the molecules are farther with each other. So you will compare now hydrogen and oxygen. Okay, so hydrogen and oxygen, which of them is lighter over the other na siya? So you think now of molecular weight. Okay, so the molecular weight of oxygen is heavier than the hydrogen. Okay, so you would think, I will never choose hydrogen already in my answer because hydrogen pala is lighter. Because if it is lighter, the molecules are not closer with each other, farther with each other. So the collisions are not high. Ganun mo siya. So there will be no bombarding of molecules with each other more compared to the oxygen. So your answer will be on oxygen na siya. But the problem, okay, the number of moles are varying man siya. Varying. The letter C, 1 mole man siya of oxygen, and the letter D, 2 moles of oxygen. Karon, you should also think, which is more having a collisions, the 1 mole or the 2 moles? Okay, by common sense, 2 moles are greater than 1 mole also. And then this mole, if you multiply this to the molecular weight of oxygen, it will contain more number of mass, which is the molar mass. The more the elements and compounds have more number of molar masses, okay, the more it has molecules to be bombarded with each other. So automatically the answer will be 2 moles of oxygen gas. Okay, has a high collision frequency. Okay, ganun siya yung mga questions na parang ano lang siya, you need to think. Okay, ganun siya. Okay, but it talks about collision theory and collision density, ha? Okay, but if you try to reverse also our questions, which of the following has a more collision density? Okay, your answer is none of the above. Why? Because the collision density formula is the number of collisions of the total gases molecules man siya. Okay? So, what man siya sum. So, in the choices, there's no sum. So, supposedly the choices will be 1 mole of hydrogen gas and 2 moles of oxygen gas. Be like that. So, the question also will trick you out. So, the answer will be none of the above. Okay? Because the definition of collision density is the collisions of total gases molecules over unit time. But your choices is not total man siya. It was presented individually. Okay? The collision of each molecule man siya. So in that alone, you will be confused because actually all of them have collision density. Okay? So you would try also to choose any one of them. But technically, the answer is wrong based on the formula because total man siya. So choices pa lang, hindi na siya pwede because there's no total gases mentioned in the choices. Ganun siya ang mga board examination. Okay? You have to think. Something like that. Okay, going back to transport phenomena. Pwede kumuha man ng transport phenomena. Okay? Because it will take a longer time. Charot! Okay. So I have here a problem. Sometimes the energy balance and the mass balance also will be included. Okay, but I did not teach you how to do it. Okay, but I will just express that during my discussion, right? Okay, it's not plainly only that continuity law lang siya, using the Bernoulli equation lang, ganon. But you have to sometimes use the mass and energy balances or what we call as the overall material balance. Okay? So, for example, this question. In a nozzle flow, do you know what is a nozzle? To regulate the flow of a fluid. Something like that. It can be adjusted. Something like that. Circular shaft like this that will be attached most of the times in the hoses. Okay, hoses of liquid hoses or gas hoses, something like that. There's a nozzle. Okay, the nozzle. In a nozzle flow, the inlet conditions are having a pressure of inlet pressure is equals to 365 kilopascal. Oh my goodness, kilopascal agad. Okay. Gauge. O gauge siya ha, gauge pressure siya. Okay. And density 1 is equals to, not density 1C, it's diameter. Is equals to 100 millimeter. Okay, the putting of letters also sometimes will confuse, okay? But this is diameter, 100 millimeter. So the unit na lang siya, dinhan yung mahibawaan. Okay? And the outlet conditions are having a pressure of 0 kilopascal. Gauge. Na 0 siya talaga, okay? And the diameter is equals to 50 millimeter. Find the flow rate, wow. And neglect various viscous effects. Okay, giniglik niya ang viscous effects na yun, marok kayo, right? The problem is very clever because the viscous effects are being neglected so that it will not complicate to your equations. Okay, ganon. And the fraction, meaning to say fractionless. The fluid here is fractionless. You will not consider the fraction losses. Okay? I think so. Okay? So we will use the law of conservation of energy equation for this. Okay? And then since we know that the law of energy of conservation composed of the continuity law and the application of the Bernoulli theorem, right? If I'm not mistaken. Okay? And then the continuity law in steady state equation. Okay, usually the point 1 is equal to point 2, gano'n siya. So, neglected siya ang recovery or loss talaga. Okay? Because in the overall material balance, there will be sometimes wastage or recovery in the middle part of the process. Then, that's why if you have an input, will be automatically equal to the output because the losses there or the wastage there in the middle of the process are being neglected. Okay, so that's the reason there because actually it is input plus the recovery and the losses is equals to the output, but most of the times man good siya in steady state flow neglected and negligible man yun ang recovery ang losses. Okay, and most of the problems are always like this also. Okay, most. But then if there is losses, then use the fraction, the fraction losses formula also in your energy equation, right? Okay, so why complicate with use it? Okay, but most of the I'm just telling you most of the times it's not being considered. Okay. Okay, ako na siyang iyag-iyag ang mga formulas and equations. And let's analyze what is the best formula and equation for this. Okay? So, mag-drawings ako. Ganon. Talaga. Okay. So, ganon siya. Ang nozzle, ha, di man siya parehag diameter. Okay, okay. Gamay mo din siya sa tumoy. Okay? So, ganon. Oh. Ganun siya. I will just close the nozzle, ha? Okay? I will just, drawing naman siya good. So, I'll just close. But actually, this is open, okay? But, saan paggawa sa tubig? Okay? The water will not flow if closed, right? But in my drawing, I'll just have to put that in close lang siya. Okay? Like this. Understood lang siya na open. Kakaloka. Okay? Ang fluid, will enter good siya diri-ari. Okay, ganon-ganon. Okay, the fluid will enter in the bigger diameter, of course. Okay, it's always started with the bigger diameter, of course, because it is the purpose is to reduce the flow. Okay, the speed of flow. So it's called a regulator, something like that. Okay. Okay, the diameter 100 meter daw siya. Okay, gano'n. So, diameter is, what's this? 100 millimeter. 100 millimeter. And the pressure, let's say, input siya. So, let's just have P1, 1 lang siya. So, D1, and then P1. P1 is, pressure 1 is equals to 365 kilopascal. Kung sa ganito, pag kilopascal, okay, so, 101.325 kilopascal is equals to 1 atmosphere siya, ha? Ganon. Okay? And, sa tupa, you convert this one, so para may mo siyang atmosphere. Okay? You divide na lang talaga siya, no? To, 301.25. Okay? Or 100, sorry, 101.325. Okay? Kilopascal. So, isa na to siya i-convert. Okay? Hayaan muna natin siya. Okay? Pasagdain lang sa itong 101.325 kilopascal is equals to 1 atmosphere. Later, if it is necessary to convert, then we will convert. But let's just as is lang muna. Pressure 1 is equals to 165 kilopascal. Okay? And then, the outlet conditions are pressure 2 is 0. So, meaning to say, it was not pressurized na siya when it goes to the outlet. Okay? So, when it is not pressurized already, meaning to say, it was not fast anymore. The flow is not really fast, right? Because it was not pressurized man siya. Di ba ganon? Okay. Okay, pressure 2 is 0 siya. And then, the diameter 2 is ganon. Okay? Flow rate siya. Guys, there are two kinds of flow rate baya siya. Okay? But some books and some reference books, or even in the websites, in the YouTube explanations, so Wikipedia, okay, Google search, anything, reference textbooks, whatever, chupa-chup, okay, like that. This mass flow rate and volumetric flow rate always. Okay, there's no density flow rate, ha? Only mass flow rate and volumetric flow rate. But the the tricky question will be most of the times in the problem solving, you will not specify sometimes if it is a mass flow rate or the volumetric flow rate. Like this, find the flow rate only and neglect the viscous effects. So you can also think through the given, because the given does not include mass, okay? And does not include also density, okay? And in the first place, the fluid flow in this nozzle was not also mentioned. This is also the, the difficult part in problem solving in engineering, because sometimes if it is not mentioned in the problem, we will assume that as water. That's a problem also. Okay? It should be specified so that the students also will not be confused. Okay? Just like this, in a nozzle flow, and the question are just telling, of course, the fluid will be, the water will be our reference, but it's not mentioned. There are a lot of fluids also that will go in the pipeline, right? The students also will be confused. Okay? Just only my recommendations to, to the books, to the whatever references. You have to mention specifically really what will be going inside the pipeline, because there's a lot of fluids and liquids all over the world. Okay, and then the student will be confused because there's a lot of problems like this also, especially in engineering. They will never mention the fluid, but it's automatically water is being understood there. Okay? Like that. Okay, so, di ba? Magunahuna jug ka, ano din, tapos wala dimension. Okay? Like this. Find the flow rate and neglect the viscous effect. So what this kind of fluid all about? Okay, but this is directly understood to be water, sure, 100%. Okay? Di ba? So, nakaloka. Okay, let's assume water lang ni siya. Okay? Assume water. Kalagot, no? Tinay assumption. Okay? Assume water passes through the nozzle. Halo, nakakairita talaga, no? Diba? Charot. Okay. So, ganun-ganun siya. So, in the law of conservation of energy, let's review the equation, ha? In the law of conservation of energy siya, so, it is thought to be always in the laminar stages, ganun, no? The laminar flow. It's not turbulent. Okay? Or else, it will undergo another equation kung turbulent na siya, diba? Okay, that's the number one. And then, correct siya. Dito, neglect viscous effects, because in this law of conservation energy, the viscosity and the shear force of the fluid running in the certain pipelines are not really the concern, because it's considered to be negligible and zero in effect, something like that in theory. Okay, that's the number two. Okay, and the number three, the relationships. Okay, if the velocity is high, okay, the pressure will be lower in the pipeline. Okay, like that. Okay, and then if the area is very big or very high, the velocity also will decrease. So these are the relationships to be considered. Okay, and then if the elevation is high, okay, the pressure also decreases. Or if the elevation is going up, okay, the velocity decreases, the pressure decreases, something like that. Okay, malong. Okay, like that. The pressure decreases if the elevation goes high. Okay? Ganon. So, mga relationships, i-consider mo sa law of conservation of energy. What else? Okay, you will assume that steady state siya. Right? So, you could say mass flow rate in the inlet is equals to mass flow rate of the outlet. And you can also say also volumetric flow rate in the inlet is equals to volumetric of the outlet, because there's no losses or wastage in the process. Walay recovery, something like that. So there's no friction losses. So neglect siya tanan, in which it is also matched in the problem. Neglect viscous effects man siya. Okay, so there's no resistance to flow. So wala siya. Meaning to say ideal fluid talaga siya. Okay, there's no resistance to flow. Resistance to flow man ang viscosity. Okay? Ganon. Okay. Now mo, imo rin siyang kuanon. Okay? So, volumetric flow rate 1. Inlet na lang siya. Kaya ba natin kasunod? So, volumetric flow rate, inlet, I gamay, is equals to volumetric flow rate Okay, out. O. Ganun lang siya. Pwede na 1 o 2. Depende naman kung mo. Okay, then volumetric flow rate inlet is equals to the delta change in the velocity times the area rin siya talaga. Okay? Take note, the mass flow rate is different ba? The delta change of the velocity or the speed times density pa siya. Okay? So, na siya density kanunay. Okay? So, di ba? So, wala siya density. We consider here. Okay? So, area diretso o volume. Okay? So, area I, not volume velocity, sorry. Maglibog ko no, okay? Tungod ba na sa V. Okay? Dapat EU na lang permi ang velocity ha. U, AI, UI na lang siya. Yun. Okay? Sama ko ang volume. V masan ang volume. Okay? Yung viscosity, V sad. Diba? Samok. Okay? So, A final equals to velocity final. Equation 1 na ni siya. Okay? Equation. Flow rate man ang ipangita. Halaha, flow rate ang ipangita. Wala ba takibaw kung mass flow rate ba siya or volumetric flow rate? Okay? Equation 2, sa man. So, kung napunta sa ono. Charot. Energy equation, sa man to. Wala, energy equation na formulated by Mr. Bernoulli. Okay? Pressure. Energy equation ni siya. Ako lang ito. E. Di ba? E. So, pressure over density plus, okay, U squared over 2. Okay? Plus GH. Right? Muna siya itong equation formula 1. Okay? Ganun siya. So, pressure. Ayun yung kalimtihan kayo. Maudyo na siya pirmi. Basta fluid flow. Okay? Pressure over the density plus the kinetic energy, velocity squared divided by 2, and the plus the gravity and the height or the elevation. Okay? So, why the mass has been lost in the kinetic energy? So, it's during the discovery of Bernoulli, he is only using a particular one mass, okay, as a basis of calculation, and then he treat that mass as constant. Okay, in which true naman talaga siya. For example, you are using water as your discovery, then you will use only water, and the water will flow to the points A, point B in the pipeline. It's just equal man siya. So mass is not a concern. That's why in this formula it was neglected in the equation, because the formula of kinetic energy na ay mass, 1/2 times the mass times the velocity squared baya siya. But you will think it's been lost in the Bernoulli theorem. Okay? Because the kinetic energy here has no mass at all. Okay? The same as the potential energy, wala na siya mass cube. Because Bernoulli treat mass as constant all throughout the flow of the fluid. Okay? Ganon. Okay, this is energy equation. Okay? Oh my gosh. Okay. Since the problem involves pressure, we need to convert this into a pressure form equation. Okay, because energy is more general man siya. Okay? So, how can we do this? Okay? So, we need to multiply all the quantities with the density. Because it's the problem, neglect viscous effects. If there's a viscous effects, it could be, linked with the density also. Okay, so we treat density as a constant. Right? We treat density as a constant. Then we need to multiply this energy equation by density so that we can cancel the density because it's not needed in the problem also aside from the fact of the theory. Okay, it's not needed also in the problem. Okay, it's assuming that there is only one fluid will go to the nozzle. And in fact, it's not mentioned, but it's assumed water. Okay, like that. So if we multiply this energy equation by density, what will remain? It goes like this. Okay, algebra lang. Okay, density is equals. Okay, pressure from I will put PF. Okay, PF like this. Okay, pressure form equation. Oh, PFE. Pressure form equation. Ganun siya. Para lang madali ka pisuwat. Okay? So, cancel na siya. So, pressure ang habilin. Pressure plus density U squared. Okay? But you will ask why the density comes back. Because if we multiply, it will comes back through algebra man siya. But the theory is not really that important na i-consider siya, mo-change siya ba. So it's only constant. Okay? For example, in point 1, the density of this is this. And in point 2, the density of this is this. It will not change ba. Okay? It's still the same. That's what we mean by treating as constant. It will be the same all throughout. Okay? It doesn't mean that you will no longer incorporate in your equation. It doesn't change lang siya. Parang ganon lang. Okay? So, this is density GH. Of course, if you multiply the quantities with density mo, tunga man gid siya. Wow. Talaga. Okay. So, the formula will be now, pressure is equals to velocity squared over 2 plus density, gravity, times the h or the elevation or the head. Head meaning the distance, vertical distance. Okay? So, take note guys, muna siya ang formula. Equation number 2 na niya siya ha. Okay? So, you have to incorporate all the given in these two equations from the continuity law and the Bernoulli theorem, right? Okay. Like this. Asa man to? Wow. So, substitute na yun. Okay. A1, AI, UI is equals to AO, UO. Okay? So, sama ng area 1 o area inlet. So, area inlet, dagan na ba siyang formula ang area? Okay? But, in here, ano man siya, nozzle. You cannot expect a nozzle is to be rectangular. Of course, common sense. You cannot expect also that the nozzle also having a, spherical shape. It's only round. Okay? Because sphere also another formula for sphere, right? Remember that one. Okay? So it matters. So you will also use the cross-sectional area siya. Okay, round man yun siya. Sa mga nozzle, sa mga hoses, sa mga pipelines, mga ganon. Okay? Sa mga orifice meter, venturimeter, mga ganon-ganon. Round chopper E. So you will be able to use the pi d squared over 4 cross-sectional area, cross-sectional area. Or you could use also the pi r squared. Okay, pareho na siya. But in this situation, diameter is given. So, ato ta sa dali. So, we will use the pi d squared over 4 because it's not radius or else mag-convert pa ka para mahimong radius. Okay? Charot. So pi saguhan na lang gina ang pi ha, nga 3.1416 ay pagsalit sa calculator. Okay, may I memorized that 25 years ago or plus the high school. So, 30 years plus. Okay, it should be inserted in your brain cells. Okay, that it is 3.1416 until you will reach 100 years old. You will never forget that that's the value of pi. Specifically if you are an engineer. Okay, it's a sagpa kung hindi mo memorize ang pi. Really. Okay, if somebody asks you, then you are an engineer, then what is the value of pi? And you cannot answer. It's really an insult because you're an engineer. You should memorize that one. Okay, pi is equals to 3.1416 kalas. Okay, no more conflict, no more war, no more argue. Okay, so pi di squared Okay, over 4. Okay, u I is equals to pi dO squared over 4 times the velocity going to the outlet. Ganon. Oh. Siya ha? Actually, anybody can solve, even though elementary student can solve this. Okay? Because it doesn't involve, it doesn't involve differentiation, integration or integral calculus, and differential equation. That's difficult. Okay? No, not difficult if you really study, okay, and you have the formulas on your mind. But what I mean is that complex. Okay? Okay. And then you have to substitute na siya ha. So, the diameter inlet kay 100 mm man siya. So, isuday mo siya. Okay. So, pi. So, 100 mm. Take note guys, before anything else, we will convert this millimeter to meter because mulubog siya somewhere along the end. Okay? So, mas nindot man yun way mulubog. Okay? So, we need to convert millimeter immediately to meter na siya. Ay, metric system, meter magid siya. Okay? Ganon. Okay. So, conversion factors na punta. Okay? How many millimeters in 1 meter? O, ganon. So, there are 1,000 millimeter in 1 meter. So, 100 millimeter divided by 1,000. Pila siya? 0.1. Okay? Ato sa isuwat ko ba? 100 divided by 1,000. So, imubra na nimo siya katulo. Okay? Katulo siya. So, 0.1 lagi, di ba? Okay. 0.1 meter raised to the power 2 over 4 velocity I. Okay. And then, outlet velocity, wala siya. Okay? And then, may diameter sa outlet, of course. Pero di gamay ang diameter ha. Tanawa na di gamay siya. So, if the diameter will be lesser, expected that the velocity will increase. Okay? Because of the relationship sa area and velocity and the speed. If area will increase, the velocity or the speed of the fluid will increase. Kung decrease ang iyang area. So, bali siya ha, inversely proportional with each other. Ganon. So, I did pag kung rakot ganin yung answer, that's wrong. Okay, that's the key. You will go back. Okay? So, pi diameter outlet, pila man siya, 50. So, pila man yung 50, move rin mo 3 sa left. So, 1, 2, 3, 0.050. Okay? Okay, 1,000 na siya. So, then if you are not really, convenient to do that, then use the calculator, ha? Okay? Bis naman sa I learned in elementary education na ganun siya. Since elementary, this is been taught na sa mga teachers. Okay? Na if negative, go to the left. If the right, if the positive exponent, go to the right. Nagaroon siya. And you have to count. So, mo muna siya ni-inject sa inyong brain cells. Okay? Muna siya, hindi na ka magamit ng calculator. Okay? Basta mga 0-0 siya. In dealing with 0-0, i-count lang mo siya per ni. O mauna tayo mong ipuno. Ganon. For example, 12 times 1 million. Pila siya ka 0. Ipuno rin mo siya. Ano to ang answer? Pero i-times to mo ang mga number, mga whole number. 12 times 1 to. Kung na rin mo siya kung ka 0. Mana siya? Okay, sa elementary education. Grade 1, grade 2, grade 3, grade 4, grade 6. O, itudlo naman na siya sa elementary. Okay, so divided by 4. Did you na siya kalitan? That's my point. Okay, U-O. Okay, equation number 1 na siya na, di ba? So, ano na punta sa Bernoulli? Sarap. Bigutom ko sa Bernoulli. Mukhaan sa kong pansit. Wow! Talaga. Oh my gosh. Kadiyot lang ha, mukha sa kong pansip, oy. Isa lang kahungin. Wow. Oh, Bisaya na gindi siya ha, with matching Bisaya. My live streaming. Okay? Okay. My goodness. Okay guys. Now, ano naman siya, calculate. You should calculate na, okay? Where's my calculator? I cannot use my brain cells to divide this without using the calculator, okay? Wait. Okay? Divided by 4. Okay lang. Oh my goodness. 7.85 4 times 10 raised to the power negative 3. Wow. Uy, adyan mo kahadlo ka ba sa mga negative? Ikuan naman gina siya. Wow. Okay? 7.854 okay, times 10 to the negative 3. UI then ang usa 0.050 raised to the power 2, okay, times 3.1416 is equals to divided by 4. This goes to 1.9635, okay, times 10 to the negative 3 UO. Okay, in this equation, there are two quantities being asked: the initial velocity and the final velocity of a fluid that goes through the nozzle. Okay, so we can compute either U inlet, velocity inlet, or the velocity outlet. But let's just choose velocity inlet, right? Because that's the first velocity you have to know. Okay, so velocity inlet is equals to ganon. Okay, UI is equals to 0.9635 times 10 negative 3 divided by 7.854 times 10 negative 3. Iganon mo lang siya. Okay? Basic mathematics lang siya ha. Okay? So, i-move na ko siya. Hindi ko ganahag na exponent na negative. Wow. Okay, 0, 0. So, 1, 2, 3. Ganon. Okay, 7, 8, 54 divided by 0.0001, okay, 0.007854 divided by 0.0196335. 4. Oh my goodness, perfect. 4 velocity outlet. Okay? I love it because whole number. Madali lang siya. Okay? This is equation 1. So our equation 1 will be velocity inlet is equal to 4 times the velocity outlet, in which you don't know how much or what is the value of the velocity outlet. Okay? So to get the velocity outlet is to use the Bernoulli's theorem. Nga pressure plus density times the velocity squared over 2 plus density, gravity, height. Okay. So, if you equate or if you let the points 1 and 2 or inlet and outlet to be equal or in equilibrium state, then you also that follow also in the Bernoulli. Okay. So, we need to say pressure inlet plus density inlet, velocity inlet raised to the power 2 over 2 plus density inlet, gravity inlet, height inlet is equal to pressure outlet plus density outlet U outlet raised to the power 2 over 2 plus density outlet, gravity outlet, height outlet raised to the power 2. I-equate din mo siya. If what you did in the continuity flow equation, you should also do that in the Bernoulli application of fluid flow. Okay? Para patas ang laban. Okay, ganon. So, let's try na siya ha. The equilibrium statement yun siya ay laminar flow ba yan? Okay? Pero kung, but if problem doesn't neglect the viscous effects, so that would be more complex. Okay, but in here, we're just lucky because the viscous effects are being neglected in siya. Okay? Ganon. Now, okay. Pressure inlet, right? Plus density inlet, velocity inlet raised to the power 2 plus gravity. Okay, gravity, density times height. So, inlet, inlet, inlet. Puro siya inlet ha. Okay? Is equals to outlet. So, pressure outlet plus, density outlet times velocity outlet raised to the power 2 divided by 2 plus density outlet plus gravity outlet times the height outlet. Okay? This is the complete equation for the Bernoulli theorem in points 1 equal to point 2. Okay? Point 1 equal to point 2. Ganun siya. So what you will notice guys, since this is only one horizontal nozzle, okay, so the elevation is 0. Okay? Unless it will goes up, it will go down. The connection of the pipeline, I mean, is not that complex. There's no 90 degrees connection, 45 degrees connection, 20 degrees connection of the pipeline because most of the pipelines are interconnected, right? There's a lot of pipeline in different chemical process plants, okay, or any power plants, okay? So that's not all horizontal. This goes up, goes down, goes to the side, like that. No. In that situation, the height and elevation matters. But in here, in the problem, it's only one horizontal pipeline man siya. Okay na siya nozzle. Okay, so we'll never consider the height. So height will be 0. Okay, the elevation will be 0. So we'll neglect the potential energy. Because this third term in the equation, in this polynomial equation, this is polynomial, if you remember algebra. Okay, in this polynomial equation, okay, the potential energy has been neglected because of height or elevation is equal to 0 because of the fact it's only a horizontal pipeline. Okay, do not force tap. Okay, like that. So, cancel na siya. Okay. So, at least na-simplify. Okay, so, substitute. Sama itong pressure. Okay, mura ta nagduwa-duwa. Okay? Like this. Okay, so pressure inlet. Naman to siya pressure, right? 365 kilopascal. I-convert na nila to siya og pascal automatically because it will complicate to the other units man siya. Okay, sa metric pascal good siya. Anyhow, you can convert pascal to Newton per square meter siya in the end. But for here now, let's just stop for Pascal, okay? No problem, okay? Basta alam yun ang kilo, okay? Prefixes are not really the preferable one, ha? You should go to the simplified, yun siya talaga, okay? So, 365,000 automatic. Pascal siya. Convert lang siya. So, okay, 1,000 man siya, kilo, so move to the right. Ikatulo. So, 365,000 Pascal na lang siya. Okay? So, 365,000 Pascal Pascal is a unit of pressure. Okay, bear that in your mind. Okay, this is equal to Newton per square meter. Okay? So, plus density inlet. Muna na akong giingon that there's no fluid being mentioned in the problem. Let's assume water. Okay, now there's a lot of density of water in a standard. Okay, standard at 4 degrees Celsius. A lot man siya. We have 1 gram per cc or cubic centimeter. We have 1 grams per ml and 1 gram per ml, and we have also 1,000 kilograms per cubic meter. So choose among the three. It is meter because it is metric system. Okay, so choose the 1,000 kilogram per cubic meter. Tinaman siya yung meter sa denominator. Okay? Ganon. So, 1,000 kilogram per cubic meter, okay, times UI. So, pila man mong UI diri? Ato din na siyang isud ang UI sa first equation. Na ang UI is equals to 4 times UO. Okay? So, this one. So, 4UO raised to the power 2 divided by 2 is equals to the pressure outlet. What is the pressure outlet? Oh, it was depressurized into zero siya talaga. So, zero pressure. So, meaning normal flow na lang siya in going to the outlet. There's no pressure involved already. Okay, so it's zero. Oh my gosh, it's become simplified already. So, very good. Wow. So, density outlet, 1,000 kilogram cubic meter times UO raised to the power 2 divided by 2. Take note, class, okay, in the second equation, we have now a common term which is UO. Of course, velocity outlet can be computed already, because only one term naman lang, not term, only one variable is being seen. Okay? So, UO. Ganun siya. So, do the math. Okay? Simple mathematics. Okay? Like that. So, 2. Okay, 365,000 as is siya ha. So, what ako siya 3. Okay, 365,000 plus. Okay. So, 4 is to the power to 16, right? So, 16 times 1,000. Okay. Or, 16 divided by 2 first times 1,000. So, 8,000. Copy the unit. Okay. Properly. So, 8,000 kilogram cubic meter. Okay. Like that. And then, this is UO. Okay? So, UO raised to the power UO. Nasama na siya. Di ba UO squared? Velocity squared. Kinamay raised to the power 2. So, if you square the number, you squared also the variable. Bear that in your mind also, ha? For example, if you square the 2x raised to the power 2, you will also say 2x times 2x or 4x squared. That will be the same here. Okay, so 4UO raised to the power 2. So 4UO times 4UO is equal to 16UO squared. Ganon. So UO squared ni siya is equals to 1,000. Wait. So 1 divided by 2 times 1,000. 500 UO. Okay? 500 UO. Okay. 500 UO. Squared should gapon siya ha. Okay, solve for the value of UO. Combine the same quantities. Okay, ganon siya. So, transposed. So, 500 UO squared. Okay. Okay, ganon siya. kilomicrometer, and then plus 8,000 kilogram meter squared. Okay, UO squared is equals to negative 365,000 because you transpose man on the other side. Okay, so i-plus na nino mo siya. So 500, okay, plus 800 is equals to 13 UO. Okay, is equals to, okay, 800, or you should also reverse if you want. Okay, if you wanted to. Okay, kay zero man ang pressure, pwede sa di mo siya i-reverse. Okay, so 500 UO squared is equals to plus 0 man ang pressure 2. Okay, pressure outlet is equals to 365,000. Okay, 1,000 plus 8,000 UO squared. Okay, so 500 UO squared minus 8,000 UO squared is equals to 365,000. Okay? Okay, zero man dyan ang pressure sa somewhere along the way. Okay? So, 500 minus 8,000. Okay? 7.5 siya. Okay? And then 365. Square root ni mo siya. Okay? Why? Kinamay raised to the power 2. Okay? So, saan man mo pag... You cannot answer if there's a raised to the power 2. You have to multiply it by 1/2. Then 1/2 in mathematics equal to square root siya. Okay? So, 7,500. So, square root of 365,000 divided by 7,500. Sige nga. 365,000 divided by 7,000. Square root. 6.98. Okay? 365,000 divided by 7,500 equals 2. Then square root. Okay? 6.98 ang UO. 6.98 meter per second. Okay? So, kung na ako yung UO nga, 6.98, and in my first equation, I have, asa naman to? Ako gi-memorized. UI is equals to 4UO. Substitute there. So, UI is equals to 4UO. So, UI is equals to 4 times 6.98. Pila siya? 27.9 meter per second is the velocity in the outlet. Oh, in the inlet, sorry. Take note, di ba? The velocity in the inlet is 27.9 and the velocity of the outlet is 6.98. So, the velocity is higher in a higher diameter. Okay? See? The velocity is 7.9. Okay? Like that. So, it's decreasing the velocity. Okay? Something like that. Okay? So, if you want to review, then review. But that's the case here. Okay? Ganon, right? Okay. So, now we compute for the mas flow rate. Kapag tamahuman ha, okay, flow rate mo dito di pangita. Okay, so ato na sa siyang i-times. Asa naman to? Sa flow rate. Okay, A1, U1 is equals to I lang, AI equals to AO, UO. Okay? Ang AI, by this photographer, ato lang na siya i-diretso kay mara man Japan na siya, no? So, 0.1 Okay. Raised to the power 2 times 3.1416 is equals to, okay, divided by 4. 7.854 times negative 3, okay? 0.007854. Okay? UI, 57.9. Okay? So, kunin mong volumetric flow rate. So, times 57.9. So, your volumetric flow rate will be times 0.007854. 0.2191. 0.2191. Okay. Volumetric flow rate is cubic meter per second. Okay. Sa outlet po siya, volumetric flow rate is equals to, okay, so 0.050 divided by 1,000 is equals to times, okay, 6.98. Okay, 6.98 times, okay, area O. So, ganon. So, 0.050 divided by 0.50 divided by 4. Okay. Raised to the power 2 pa siya ha. Ay, yung kalimutan na. Okay. Times 3.1416 divided by 4 is equals to, okay, ganun siya. So, times 6.98 is equals to 0.0137253 cubic meter per second. So, ang atong volumetric mo na siya, volumetric flow rate of the fluid inlet is 0.2191. Okay, 0.2191 cubic meter per second. Okay, and our volumetric flow rate going to the output is 0.0137053. See, the volumetric flow rate is lesser in the outlet, then it has a high velocity. Okay, and the volumetric flow rate in the inlet, okay, so it is big, so the velocity is less. Okay, so meaning to say the volumetric flow rate is inversely proportional to the velocity. Okay, because as it goes in the outlet siya, okay, it decreases. Okay, ganon. Okay, if the volumetric is very high, the velocity will decrease man siya, which is ganon. Okay, you get the point? So, nakuha na siya. So, our volumetric flow rate inlet is 0.2191 and our velocity, volumetric flow rate outlet is 0.0137523. But the question here, find the flow rate, right? Ganon lang siya. Usarigi pangayo. Okay? Like that. But actually, duha man siya ka-flow rate sa pagsulod o sa paggawas. Okay? It depends na sa choices, right? It will be there if it is an examination, right? So, ganun siya. Thank you so much for listening for this problem number 2-0015. Saan man siya nga source? Charot. Source. Saan siya? Mass, energy, and momentum balance. Okay. Chapter 2. Chapter 2, problem 02-0014. Okay? If you want to solve, then go there also. Okay? Website. There's a lot. Okay? Like that. Ganon. Okay? So, here's another problem. Okay, water is flowing at a velocity of 3 meter per second in a constant area pipe, which is 500 square centimeter. Here is very lucky because it's mentioned as water. A water jet with a velocity of, oh my gosh, it looks like complicated. 57 meter per second enters the pipe at section 1. Okay? Jet area may be taken as 45 square centimeter. Assume one-dimensional fractionless. So if there's a assumption also, okay? Assume one-dimensional fractionless flow and the pressure of the jet and the water flow in the pipe to be designed as section 1. Oh, this makes it easier, right? Because the pressure and the water flow are ano man siya, constant. Okay? Calculate at a section 2 far away from the jet. Wow. The average velocity and the pressure gain, wow, is pressure 2 minus pressure. Of course, no need to mention because average pressure gain naman talaga siya, diba? The average velocity and the pressure gain is pressure 2 minus pressure 1. Okay, in here, the same story. Use Bernoulli theorem, the continuity equation also. But it depends on how you attack the analysis of the problem, ha? Let's solve this. Okay? Ang gutom ang koy. Wow. So let's stop for a while and let's go for another session of this problem solving later. Guys, if you haven't subscribed yet my YT channel, then you can subscribe now if you want, and then you can click the notification bell of some newest updates of OSH Eternal Voice, Engineer Sotero, Engineer, okay, and then OSH Engineer. Okay, thank you so much, guys. Bye bye. God bless everybody.